So yeah, once again, for those of you who don't know me, my name is Giancarlo. I'm from EGaDS, that is the game development organization on campus. And today we're doing a workshop on scripting in Unity. So who here has, kind of just to get a feel for level of experience, who here has worked with a game engine before? Okay, cool. Uh, who here has heard of Unity? Okay, awesome. Okay, so first of all, for the half of you all that haven't worked with a game engine before, let's talk about what is Unity and more broadly, like what is a game engine? Game engine is just a set of tools that are going to support you in making games, right? So they'll give you a system for physics, a system for rendering graphics, lots of systems for audio and music. And what we're concerned about today is what system are they going to provide us for like writing code and scripting? What kind of tools are they going to uh, give us access to so that we can organize how the logic of our game works? Okay, so Unity is just one of those tools. It's free. It's very robust. So that's what we're going to be going over today. So my two main goals for this workshop here is, first of all, how is Unity scripting system structured? This will involve basically a very basic overview of the Unity engine in general, but we're going to be mainly focused on how do scripts work. So how do we actually use the logic? And later on, we'll touch on some more slightly possibly advanced considerations of like strategies that we could use to deal with what are the most common scenarios that we find when we're making games. Okay? So I'm going to cover a fair amount here, but I'm going to do it pretty quickly and in such a way that hopefully if you are planning on doing something game development related, either now or in the future, you'll think of some of these scenarios and then you'll kind of know what approach to take. Okay. Even if you're not directly working with Unity, or even if you're not directly working with a game, the way that Unity structures their systems and their scripting is actually quite nice, and I think it's worth taking a look at and something you might even bring over into other areas of programming. Okay. So what we're going to cover today is just Unity and component systems in general. We'll get into what exactly do we mean by a component as we go on. This will be just kind of a basic overview of Unity. So if you've used Unity before, this will be basically just review, but we should have a good sort of solid understanding of how it works. Then we'll get into kind of how do we write scripts? So what is a script? How do we make one? And then we'll get scripts to talk to each other. This is where the main kind of interesting part of this is, because games have a lot of different systems that have to work and play nicely with each other, and that's not always an easy thing to do. So we're going to get scripts to talk to each other, and then I'll give you kind of some general pointers of like, where can you go from here? We're aiming here for around 45 minutes to an hour, just so that you all know, and so then that's what we'll go through today. First of all, let's look at this kind of class hierarchy here. We have here kind of a tree structure, and we have this inheritance hierarchy. And so this is something you might do, or you might think to do if you were trying to structure kind of classes for a game. You might say, well, games have things in them, so we'll have a class for an entity. And we have different kinds of entities. So we have things that don't move, so we'll call those static. And then we'll have things that do move, and then so we'll call those dynamic, and then we'll split up the functionality between those. And then you can start getting into the specific things you might have in your game. So you might have like a rock and a tree. Those things will be like static. They're part of the environment. You might have like an enemy and a player. Those things have to move. They have to have extra logic around them. So we might say those inherit from the dynamic class. And then we build this kind of inheritance hierarchy, right? Without going too in-depth into sort of what are the details of implementing something like this, right off the bat, does anyone see any like potential problems that we might run into if we structure our classes like this? Yes. Yeah, exactly. So you bring up a good point, right? Things don't always fall so neatly into categories like this, right? So an example is like, what if you want an evil tree, right? What if you want something that inherits both from the functionality of trees and inherits both from the functionality of enemies, and they kind of, you get into multiple inheritance, and this is just gross and we don't like it, right? So I'm not going to say never to use inheritance. Inheritance has its place. But what most game engines will do, and what Unity will kind of try to enforce, is something more like a component system. So we have our different things in the game. So we might have trees in our game, we might have enemies in our game, we might have players in our game. right? And they're all kind of just composed of different little bits of functionality, right? So clearly all of these things have to have some position in the world. So we'll have a position that has an X and a Y. Some things might have AI, right? So your enemy has to move in a certain way. So we'll just slap an AI component on there. We have to show things. So when we show things, we call that sprite. So we'll put a sprite component on them, and so on and so forth. AABB, if you don't know, is an axis aligned bounding box. All that means is that we have a shape that we're going to use for collision, and it's going to be aligned to the axes. So no rotations or anything. It's a nice, simple way to do collisions. Not important to what we're covering here, but just so that you all know what that means. We might want things to move, so we'll give them velocities. We might want things to take inputs, so we'll give them inputs, right? So you can basically build up your parts of your game from these components. And then so this is the kind of structure that Unity is going to try and enforce. Okay, so when you open up Unity, you're going to see an interface that looks something like this. And if you're anything like me, this is really gross and overwhelming, but hopefully we're going to kind of pick it apart and you'll kind of understand more of what we're looking at here. Okay. So broadly speaking, you can divide this up like this. Here we have kind of our game view or our scene view, right? This is kind of where do we show what's actually happening in the game. We're going to have our hierarchy, and this is where the things that we call game objects are going to go. Game objects we'll see are just any kind of thing that we have in our game. It's a deliberately very vague word to use, but it's vague because anything is a game object, right? In the inspector, this is where we're going to get into some of our components. So we're going to have game objects that have components, and we're going to be able to kind of mess with them in the inspector. And then you have just your assets folder here. This is where all of your files are going to go. So all your code, all your sprites, images, music, audio files, all of that is going to go in the assets folder. And even some objects we'll see are going to go in the assets folder, but we'll get to that in a bit. So the first thing we have to understand is what is a scene? Scene is just the physical space that your game takes place in. So that's shown in the scene view here. We can connect multiple scenes together. And then so that's how we get like our main menu scene. That's how we get our like level 1, level 2, level 3 scene if you're making some kind of game that works that way. So you can have different rooms, main menu pages. You can connect them together into scenes. So a scene is just a space where the game takes place. We have coordinates measured in units. So if I open up Unity here, I've just made a blank project. And you can see that we have this kind of coordinate system. It's split up into units. By default, this could be arbitrary length. We're going to set it to 100 by 100 pixels by default. This is changeable in the inspector. For example, if you were making a pixel art game, you could go in and make these like 16 pixel units if you wanted to. But we'll stick to 100 by default. So all scenes are technically 3D space, but in 2D, the z-axis is not used. What do I mean by all scenes are technically 3D space? So here I've opened up a 2D scene. If I go up here and I actually click this here, you can see that we can now view the world in 3D, right? So difference between a 2D game and a 3D game, not really much. We just hide the z-axis, okay? Then how do we actually view the game world? We have this thing called a camera, right? And the camera is just what do we see, right? So you can see here that if I go, we have this camera. And you can see this doesn't really look how you would see in real life, right? This is kind of just a straight line that goes forward. And, you know, that's not really how we see. We see in kind of a cone vision, right? So the way you're probably used to seeing is something called perspective vision, right? This is what we would use in 3D. In 2D, we're going to be working with something called an orthographic camera. So depth here does not matter. So that's all we mean when we say we're making a 2D game, okay? This will be important when setting up the camera because you'll notice that the camera does have a z-axis location. It is set to -10 on the z-axis. And so what that means is that it's behind, and then so it's going to be showing everything in front of it, okay? And if for some reason you accidentally reset the z-axis of the camera to be 0, you're going to run into a lot of painful bugs where you will not be able to see anything and you'll have no idea why. So that's always something I check first if something like that seems to be happening. Okay, let me open up this. Okay, so now we have game objects. We've already seen one example of a game object. It's the camera. Those are the things that live in the hierarchy. They can be literally anything. They can have a physical representation in the game, so they can be like players, spikes, platforms, stuff like that. Or they can be like very generic logical things. So like an enemy spawn manager. So something that's going to it be in charge of spawning enemies into the game. Or maybe you have something that's in charge of coordinating like scores, right? Or anything like that. Any high level logic can also be a game object. It just won't have a physical representation in the game, but it's still there. We do always give our objects a position in space. So if I go in here and I make right click, create empty, this is going to make a new game object. And you'll see that no matter what, we have a transform. Now this transform doesn't actually matter. So most of the times you can just reset it, right? If right now it doesn't matter because we're not actually showing anything, right? But we are required to have a transform on all of our components. So they can be categorized in different ways, and we'll get more into this when we talk about scripting. So how do we actually communicate between objects? We'll talk about how we can identify game objects. And you can nest them inside each other to create kind of parent-child relationships. So I'll talk more about the parent-child relationships once we get to components, because then you can kind of understand why this is really useful and why we call it a hierarchy, because there are different levels and we can put stuff inside of other things. And so that creates some really useful structures for us. So what is a component, right? A component is what actually makes a game object do something. So it's what actually gives a game object any of its functionality. So you can think of a game object as literally just being a container for components. It's a place where we're going to pick components, but all of the actual like stuff that the game object does is contained entirely within the components. So we're going to build up our game objects as basically just a bunch of components. So they're what actually do things. Components have what we call fields or properties that you can set. So you can change how a component behaves. For example, if you have a sprite component, you can change the color of that sprite. So that's a property of the component. And we'll go through an example here. And almost all the code you write, so what's going to matter for this workshop is almost all the code you write is going to be essentially just a process of reading components, processing them, and then updating them. And then you're going to just do that over and over again. So these are sort of examples of different components you can have. You have to understand what they do. You don't have to understand all that they do right now, but just to give you a general idea of what is this engine going to give us out of the box, right? A transform we've already seen. A transform is literally just a container for a position, a scale, and a rotation. So it's just where in space is our game object. The camera we've also already seen is going to define how we see the game. The sprite renderer is going to be how do we actually show, right? How do we actually show a game object? So what is the image we're going to display? We have rigid body 2Ds and collider 2Ds. Rigid body 2D just indicates that this will be an object used by the physics system. Collider 2Ds will kind of define bounds for collisions, right? We have audio sources for playing sounds, animators for doing animations, particle systems for particle effects, and then scripts are what we're going to make. So scripts are components like any other. They attach to game objects, and they're going to manipulate the settings of all the different other components that we add, and that's what's actually going to give us the behavior of our game. So I'll go in here just to show an example. So we've made this empty game object. I can click up here to rename it. I'm just going to call it my object. Okay. And I can go here and add component. And you can see all the different things that we can add. I'm going to go and just so that we can actually see something, I'm going to go and go into here. I'll just search because I don't know what dropdown it's under. Sprite renderer. And then you can see we don't have a sprite yet. I'm going to go in here. And actually, I'm going to put this here in my assets folder. So I can go right click in the folder, create, and then somewhere here should be a setting for sprites. And I'm going to make this a circle. Okay. So I have a circle sprite now that lives in my folder. This is just a PNG, right? I'm going to my object and I'm going to select the circle. So if I go back into 2D mode, you can see that we have a circle. And then if I run my game by pressing click here, we have a circle here. Okay. So my object, a game object here, is just a container for a transform and a sprite renderer. So it has information about its position in space, and it has information about what it's going to look like. So this is kind of the model that we're looking at right now. So we have our scene, which is a container for game objects, which are a container for components. And you can see here, I've also put a game object inside of a game object. So that's what we're going to talk about now. is, oh, and this is just showing that you can have different scenes that transition to each other. So you build out these scenes and you have maybe levels and the settings menu. What we're going to look at now is parent-child relationships between objects. So I made an object that's a circle, right? And I can add stuff to that, right? I can put stuff inside that. So when we do that, we're calling that one object is the parent of another object. So if I go in here, and I can actually just drag in this, and it'll make a circle here that has the transform and the sprite render. I'm going to put the circle in here, and I drag that in, and then so now this circle is a child of my object. I'm going to name this to parent. I'm going to name this to child. Okay. So right now they're both just the same thing, but I'm going to take the child and I'm going to set its x position to, let's say 5, right? And so the important thing to know is that it inherits all of its transform properties from the parent. So the parent here has a position of 0, 0. As I move, you can see the child also moves with it. Okay? And if I move this here, and if I rotate on the z-axis as well, you can see that its child moves with it. So all of this is relative to its parent. So that's going to be really useful for a number of reasons that I'll get to in a sec. And another thing you have to know is that the lifetime of a child is determined by its parent. So if I disable a parent, I disable all of its children. If you destroy a parent, you destroy all its children. We already saw how the transform is linked to its parent. So that's called local space, right? So you can see in here that the child is just at an offset of 5, 0, 0 from the parent. So that is a local space, right? But the parent is in world space because it has no parent. It's just a child of the scene. So how do we actually use parenting to its advantage? Like, what are the actual practical advantages of this that we would use when we're actually making a game? One of this is storing like extra metadata, right? So let's say we have a wall in our game, and we want our wall to have different waypoints around it for, let's say, pathfinding. So an enemy can move around a wall using these points that are stored as children of the wall. So these waypoints here will define how an enemy can move around a wall. And we just simply store those as data inside as a child of the wall class, of the wall object. So this makes it really simple to just add a bunch of extra data into your objects just as children, and then they're pretty neatly contained inside of there, right? The other thing is, we talked a little bit about colliders. Colliders are how we define collisions for the game, but we can have multiple kinds of collisions. And so we can say that maybe whenever there is a bullet, right, that should use one collider, and whenever there is an enemy, that should use a different collider. So I can add different colliders. You can see this one has a bit of a round edge, right, and this one has a square edge. We can have those different colliders, and one of them is just contained as a object in a child of that wall, right? Some other just more common examples are we can have our levels as game objects, right? We can have our levels as just empty game objects that are containers for other game objects. So you can see this level 6 here contains different enemies here. It contains different walls here. We'll get to what it means that this is blue in a second. We'll get to what exactly that means, right? But all of these objects are contained within these level objects. And by enabling and disabling them, we can load and unload levels, right? So we can contain things inside them and tie all of these objects to the states of the parent object, right? Another thing is we can define, right, different points within different objects. So here I have a player, and let's say I have a ground position, which is just a transform that exists at the feet of the player. So when you're making a platformer, some useful information to have is where is the player's feet, right? Because that's how you detect where are you touching the ground, right? So we can have that as a child of the player. So this ground position will always point to the player's feet because its position is tied to the player, right? You can also use this as like kind of pivots. So here you see these two orbs that are kind of rotating around a midpoint. What we can do is we can have the actual object itself be the midpoint and have the two orbs that you actually see be child objects that are at some offset. And then by rotating the center pivot, you can actually just get all of them to rotate around, right? So that would look something similar to like, here's our pivot, here's our child that's at some offset. And then so by rotating the pivot, right, what otherwise might be like a relatively complex calculation to get this to rotate around the center of the object becomes super easy. You just change the rotation uh, of the parent object. So pivots are really useful when you're dealing with parent-child relationships and objects. Okay. So this is all we've been over right now. We've just kind of divided up the space of the Unity interface, right? And one thing we haven't really gone through is kind of project files. Project files are where all the sort of the stuff that does not live on a scene will go. So things like your animations, audio, fonts, all that will live in there. We'll get to what a prefab is later. But for now, we can start to talk about scripting. Okay. So this is the main part of the workshop that I want to go over is how do we actually write scripts for games, right? Specifically with Unity. This will apply to basically any video game ever. Video games are essentially one massive while true loop. We're going to sit there. We're going to do the same thing over and over again. We're going to read the state of our game. We're going to do some processing, like we're going to process our inputs. We're going to run like physics calculations. We're going to do a bunch of stuff. And then we're going to write that back to the state of the game, and we're just going to do that over and over again. So in Unity, we have an entry point that's called a start. So every script will start at a certain point, and then we'll have our update loop, which literally just does the same thing over and over again. Okay. So if I go in here and I'm going to add component, I'm going to call this test script. And then so we add our test script here. I'm going to open this up. And you can use any IDE of your choice. Default for Unity tends to be Visual Studio. So this is what your script looks like, right? And then we can break this kind of apart. We can see that here's the name of our class, and then we have that it inherits from mono behavior. By the way, Unity uses C#. It's basically Java. So if you know Java, you'll be able to follow along with us. At least syntactically, it is just Java. So we inherit from mono behavior. And what that tells us is that this is going to be a component. So it's going to be a component like any other component is a component. It's going to be a thing that attaches to game objects. Okay. So we have our start point. And I can go ahead and I can make, let's say, an integer count. And I'm going to set it to nothing for now. And then when the game starts, I'm going to say, I want the count equal to, let's say, 10. And then every update frame, right? So this is what's going to happen over and over again. I'm going to print count plus plus. So we're going to print the count and then we're going to add one to it. So we go back here. And then so we see we added this test script as a child. And so when we run the game, we see that every frame is just going to keep counting up. So it's going to count up really, really, really fast, right? So every frame, we are adding one to this count. And you can see that it just keeps going, even if I clear the console, right? So that's kind of showing you that this update function is really just a while true loop that runs every set amount of time. Okay. So obviously counting up is not very useful, right? So how do we do like useful things with this, right? So all of the scripts you write are essentially going to be you read some component, you process that component, and then you update that component right back. Okay. So if you wanted to move an object to the right, you would get its transform component, you would add one to its X value, and you would update that back, right? So this is more or less what that would look like, right? We can have a variable of component type, we call it component, right? And you can just fill in whatever type of component that would be. Then at the start of the game, so whenever this component is actually loaded in, right? So not the start of the game necessarily, but whenever the object is actually active in the game, we're going to say that component is equal to get component, component type, whatever that might be. It could be a transform, it could be a rigid body, it could be anything, right? So we're going to get that component. And this will search, this will just do a linear scan through your object, looking for components of this type, and it'll just give you back whatever the first one is, okay? And then we do some work, and then we update whatever field of that component we're worried about, right? So we can do kind of a basic example. I'm going to delete the child for now. I'm going to reset the transform of this object, and let's get this to maybe do something a bit more useful. Okay. So what I'm going to do is I'm going to give this a rigid body 2D. Okay. And I'm going to start this over here. And I'm going to basically just have this move to the right of the screen. So you can see that the rigid body 2D component gives me some properties automatically. I get a mass, I get a gravity scale, I get all these different things. You really only have to worry about what you're actually using. So for my purposes, right, if I were to click this now, you would see that it would just fall straight through the ground because the gravity is non-zero, right? So that functionality is being calculated by the rigid body component. I'm going to set gravity to 0. Okay. So right now we have a rigid body that does nothing, but it has that functionality of a physics engine. So we're going to be able to update it and manipulate it to do things that we want. So we go back here. And then we're going to go in here. And then we're going to say rigid body 2D, RB, RB equals get component rigid body, RB dot velocity is equal to just, let's say 1. Okay. And this is actually going to want a vector. So I'm going to go new vector 2, vector 2, 1, 0. Okay. So 1 in the x-axis, 0 on the y-axis. And then we're going to go back here. And then we'll see it just moves to the right. Okay. So everything you basically do will just be varying levels of complexity of this. You read, you update, and then you just keep going. Okay. So when we're dealing with a while loop, we're going to want some concept of how much time passed between the last frame and this frame. So when we were using a rigid body, the physics engine is going to take care of smoothing out that velocity. But let's say we wanted to directly just add 1 to the x component of our just position. So let's say we want to modify our position directly. We say transform of position is equal to this vector 2, take the current x position and add 1 to it, right? If you have different frame rates, right, this is going to move twice as far as this because this will update twice as much as that. So what we do is we have this concept of time dot delta time, which will tell us what was the time between frames, and then we can move forward by that much scaled by some speed. So here at 5 FPS, our delta time is larger, so we move by a larger amount every frame. So this is what's going to help us synchronize our movements there. And then so if we do something like this, where we add to our x position speed times time by delta time, we're moving at speed units per second. What does a serialized field mean here? Serialized field means that this is going to be a field that's exposed in the inspector. So remember, our objects are containers for components. Our scripts are a component like any other. So when we say serialized field, right? When we say serialized field, I'm going to say flow at speed. And then we recompile this. And then we open back up. We see that now I have a speed variable in my inspector that I can edit like I would any other component. Okay. So I can put, let's say I want the speed to be 5 here. And instead we can just set speed here. So we'll move to the right at speed velocity. Right. So here it moves a bit faster. You can change this at runtime. So if I go here and I drag, I can make it faster, I can make it slower, I can make it go negative, I can do what I want with it, right? So when I go back here, right? So when we're using rigid bodies, we don't have to worry about delta time. The physics engine takes care of making sure that the frame rate is consistent. But if we're moving directly with position, so manipulating the position, we're going to want to do something like this where we scale by delta time. So any time where you care about the distance of time between frames, we're going to scale by time dot delta time. Okay. So here's just another example of that, where these are exposed in the inspector window. Okay. So we also have this concept of a fixed update, where we do physics calculations, and an update where we do game logic, right? So update is what we've been working with. It runs at an indeterminate number of frames per second, and this is where you're going to put all your game logic. It just happens all the time. what Unity and most other game engines actually do is they actually have a separate fixed update where they do all of their physics calculations. The reason we call this fixed update is because physics engines really like their frame rates to be stable, because if frame rate is varying a lot, as it is in something like this, you get kind of unstable simulations. So we really like all of our physics calculations to go into fixed update. So really the better way of doing something like setting the velocity of our character would be to do this in fixed update, right? Where we go and we actually update the velocity of our rigid bodies. Okay. So really all of our physics calculations are going to go in the fixed update function, and that's going to improve stability. Here. So here's an example of how you would do a basic player movement script. So go over here. This should look familiar. We have a serialized field for speed, right? And then we're going to paint our rigid body in the exact same way that we did here. And then we keep some other vector too. It's just extra data called movement. And every frame, so this is game logic here, we're going to read the input, and there's this function that Unity gives us called getAxisRaw. And what getAxisRaw means, so horizontal is just going to be arrow keys left and right. Vertical is going to be up and down. So this is going to give us a 1, -1 on the x-axis, or 1, -1 on the y-axis, depending on whether there is inputs. And then in our fixed update, we're going to actually update the velocity of our character using what we calculated up here, right? So this is going to be equal to move input.normalize times speed. Why do we normalize? So normalizing a vector, if you remember, means making a vector of length 1. So you can imagine what would happen here if we have our move input. If we're pressing both up and to the right, our move input will be 1, 1. That vector has length of square root of 2. We don't want that because then the player will be moving 40% faster on the diagonals. So we go ahead and normalize the move input, make sure it has a length of 1. So its velocity will be a consistent speed every time. So this is how you make a basic move input script that just moves up, down, left, right. And you can see how it's just basically a continuation of things that we've already done. You get your components, you do some calculations, and then you write back to them. We also have some collision events. I'm not going to go too deep into these, but you can have sort of more event-driven things where you have functions that are called when colliders enter other colliders. So if something collides with something else, there are callback functions to help you deal with that. Let's talk about prefabs. So prefabs are reusable game objects. So we have a lot of game objects in games that we want to basically reuse. So we might have different enemies. We might have different sort of projectiles. Let's say you're making a top-down shooter and you have like lots of different bullets, right? So those are things that we really want to be reusable, okay? And so we call these prefabricated objects. They already come with components. They come with default data. They come ready-made for you to spawn into the game, right? These are things that are created by the programmer, and they live in the project files instead, and they can be dragged into any scene, okay? So if I go in here and I drag this into here, right? This is now a prefab, right? And that's where it turns blue. So then I can go in and I can drag in as many of these as I want, right? And if I go in here and let's say I actually want these to be red, I can right click and say apply to prefab, and now all of them get updated. So this is really useful if you're working in a team because you can sync up changes between objects. So if you have like 10 different enemies, right? If you make a change to one of them, you might want to synchronize that to all of them. So this is really useful. And so these live in the project files instead, right? So my prefab now lives here, and I drag it in here, and now it becomes a game object in the scene, right? They're great for synchronizing changes, and they're good for making new objects. So these are the things you would spawn in if you want to spawn in something during the game. Okay, so that's kind of the basics of how scripting works. Now let's kind of talk about how do we actually get multiple objects to play nice with each other, right? So if you're within the same object, we've already kind of been over this, right? You can just get component, or you can serialize field it and set it in the inspector, right? So if I'm in here, and actually let's say that I don't really want to get component on the rigid body anymore, I can go in here and I can serialize field. And then when that updates, you can see that my parent now has a field for rigid body, right? And so I can go in here and select this rigid body, right? Actually, I can go in here and I can select any other object's rigid body. As long as I drag in a rigid body here, it's okay with that. So you can drag in any rigid body in here, and that's okay. Okay. So you have two options if you want to get components within the same object. What if I want to get components for different objects? Well, first I need to actually get a reference to that object. So Unity is going to provide you 3 different ways of finding, right? We're just going to be find by name. So find by name is going to be just look through the entire scene hierarchy and go look for a object that has that name. This is going to be a bit iffy because sometimes you rename objects, right? So then you don't want to have to go into your code and change all of your find, right? So really, we're predominantly going to use the next two. We're going to use something called a tag. What a tag is I can go in here, and I can go to my parent object, and here you can see we have some tags already. Let's say this is a player, right? I can also add tags and add a bunch of tags to my list. So I can call this my tag. I'm going to save it. And I can go in here and I can tag an object as my tag, right? And then so now I can find any object that is tagged with my tag. So we have a couple options here. We can either find all of the objects that have that tag. So if there's multiple things with that tag, then it's going to be used find game objects with tag, right? And that's going to give you back an array of all of the objects that have that tag. Or we can do find with tag. This would be if you expect there to only be one of those things, then we just retrieve whatever the first active game object with that tag is. Or you can just set it in the inspector like we saw. So how do prefabs get references to objects? Because we said that fabs live inside of the scene, right? So if I actually go into my prefab and I open it up, right, you can see its world is defined basically by itself, right? It exists by itself and it exists in the file system, right? So anytime I want to get a reference to something, right, here through the inspector, you can see that I can only access, right, things that are kind of within its scene. So if you had a prefab, let's say an enemy, and it needs a reference to the player, then what you would need to do is you would need to call find, right, when the game is actually loaded in, and then you can go find, right? So you need to actually call find once the game has already been loaded, and then you can go, because the prefab lives in the file system, so it has no knowledge of anything going on inside the game, okay? So that's how prefabs get references to objects. But we've kind of talked about everything as being built up by very individual components, right? But sometimes you really, really want global data, right? So what do we do there? We make a singleton, right? I can make an object, right? So let's say we want some global information for all of our enemies in the game, right? This could be for any number of reasons, but oftentimes we want our enemies to coordinate with each other through some kind of global data, right? So I make an enemy information component. It is a component because it is still tagged with mono behavior, even if it is just a component, right? We can make a object in the scene called, for example, right, game controller. And this object has no physical representation in the actual scene. It just lives there and it's a container for my component that has all the global information. So even though this is global, it still lives as a component in an object in a scene, okay? And what we can do is we can make a public static instance of that enemy information class. And then once we awake, this is kind of like the start that happens before starts. So this is the await call. We set instance equal to this. So we just set the instance equal to whatever spawns into the game world. And if there's more than one, then we want to destroy it, because by definition, a singleton is only one thing, right? And then so now anything can access it by just calling enemy information.instance and have access to all of these things. In this case, what we really care about is like, is player alive? We want to notify a bunch of enemies if a player dies. So we can have this notify enemies of a player death event, which will set is player alive equal to false. So then now anybody who wants to read this can go and find enemy information about instance, look at the is player alive field and can actually access that. Right? So that's how we can make something with global data, and this comes in handy a lot. Singletons are bad sometimes. You definitely don't want to do this too much. You don't want to do this too much for the same reason you don't want too many global variables in your code, right? Basically, you want to make sure that this is actually information that needs to truly be global. Otherwise, you're just kind of giving everything access to everything, and that's going to get hard to debug sometimes. So you should limit how much you do this, but sometimes you do truly need global information. But if you need something more sophisticated, you saw that we were kind of getting at something here when we had this kind of notify enemies of player death, and we just kind of modify this field and then let everyone read from it. We want to do something a bit more sophisticated sometimes when something happens in a game and we want to notify a bunch of things of it. So maybe if the score changes, we want to notify a bunch of different parts of our game that the score has changed. So we can do something called observer pattern. And C# is really nice because it builds this right in. So what I can do in C# is I have this thing called a game state controller. Okay? It is also a component. We'll define it in the exact same way. And C# has these things called actions, right? So I can make a public static event action. So this is for a game where the player can take possession of enemies and also unpossess them. So take control of enemies and then lose control of them. And so we have this action for when the player possesses an enemy. We have this action for the player gets out of an enemy, so loses control of that enemy. And then we also have actions for whenever the game's over, right? So then in your like enemy state, right? So in your actual enemies, right? You can access that game controller and you can do this plus equals notation, which will add your own function to that set of actions, okay? We say game controller.player possess is going to call this function. Game controller.player unpossess is going to call this function, right? And then on destroy is another event we can call, and that just unsubscribes. So plus or minus to add a function to call, minus equals to subtract a function to call, right? So we can subscribe and we can unsubscribe whenever this enemy dies. And then all we have to do is call gameover.invoke in our game state controller. So whenever game controller decides to call game over, everything will be notified, right? Everything will be notified. And the best part of this is your game state controller, the thing that's actually doing the notifying, doesn't need to have any knowledge of who is subscribed and who is unsubscribed to you. Anything can add itself, anything can unsubscribe itself. It's totally on the responsibility of the user of the game state controller to define how they want to listen into the event. And so all game state controller has to do is call gameover.invoke. So this will be really useful if you, for example, want to notify everyone when the game ends, because everyone has to do something different when the game ends. So you just call a game over invoke, and anybody subscribed to it, right, where you add yourself and then unsubscribe yourself when you destroy it, will be able to have access to when that is called. So this is how we do stuff in an event-driven way, because things are just going to happen in games, and you don't necessarily have the exact time that that's going to happen, because it all depends on player input. Let's talk about some like very common optimizations that you might encounter whenever you're making a game, right? So here's a problem. Dynamic allocation is really, really slow. So let's say we're making a top-down shooter, and that top-down shooter is going to involve like spawning in a bunch of bullets, right? You have some kind of player, they have like a machine gun or whatever, and so you have to spawn like 100 bullets in a second, right? If you're calling new on every one of those things, that is going to be really, really, really slow, right? Because it has to go find memory for that, allocated, spawn it in, right? So what is the solution to dynamic allocation being slow? The solution is that you just don't do it. So we get into these things called object pools. And what an object pool is you can have an array of bullets and you can spawn them in at the start. Because when the game is being loaded up, you don't really care about performance, right? If you're on the loading screen, if things take a second to load, right? A second is an eternity when you're in the game, but in the load screen, no one really cares, right? So when the game is starting up, you have free reign to basically do whatever you want, right? So what we're going to say is we're going to start the game off. We're going to have an array, and we're just going to make like however many bullets we want, right? We're going to make n bullets, and we're going to set them all to be inactive. So what happens when you're actually playing the game and you want a bullet? You go into the pool of bullets, and then you enable one. You set one to be active, right? So all your dynamic allocation is done at the start when you don't care about performance. But when the game is actually running and we need to sort of keep things running at 60 frames per second all the time, you just go into the object pool, you pull one out, you enable it, and then you put it back. You disable it whenever it's ready. So now the process of spawning a bullet is not like calling new. It's just going into the pool, the array of bullets, finding one that's inactive, enabling one, and then disabling it again whenever it is no longer being used. Unity makes this really simple because we can go in here and the enable tag is literally right here. Anything here will be disabled, anything here will be enabled. So with any object, you can just simply call it disable or enable. You can do the same thing with individual components, right? So this is a really useful thing that we can do. Now you might be asking, doesn't this mean that we actually have to limit how many entities we can have in a game? Like if I say I will upfront allocate 100 bullets, does that mean that our game can only have 100 bullets? Yes, actually it kind of does. You can technically grow this, but we're just gonna kind of accept it. And actually there are some pretty funny bugs in games that happen. This is Terraria. There's a kind of bug where you can put bunny spawners everywhere and just spawn however many bunnies there are, and then you reach the limit of entities and then no other enemies will spawn. And then of course that makes the game like trivially easy. A similar thing happens in Minecraft where basically your first chunk around spawn is always loaded in. So if you manage to get a bunch of enemies in just a hole at spawn, nothing else will ever spawn because that chunk is always loaded, right? So yes, this is actually something that happens where we reach our max entity count and then we just kind of can't do anything. So just be careful whenever you're doing something like this. Make sure that your count is high enough and that there aren't situations where you can kind of cheese this and just max out the entities in your game, right? Not all things have to be object pooled. There are various extremes of that, but anything that you're going to be sort of dynamically allocating all of the time repeatedly, you're going to want to make some kind of object pool for it. So as a last little bit of code that we can go over that might be useful to you is we're going to make something to manage audio for us. And this is going to combine a lot of the tricks that we've gone over so far. So the basic principle of our audio controller is that we don't want to clog up our game objects with a ton of audio sources. So if I want to play audio in a game, what I would have to do is I would have to go in here and I would have to add a component. And you would have to add in an audio source. And this is where you would drag in your audio and everything like that. So if your player makes a sound, if your enemies make a sound, if you maybe have some background music, right? You're gonna have all these different audio sources that are kind of laid out everywhere. And that can keep kind of hard to, that can be kind of hard to track when you're actually kind of having to manipulate things. The other thing is if your player makes like 10 different sounds, then your player needs 10 different audio sources, and that makes you have to scroll quite a bit, and that's kind of unpleasant, right? So the solution we're going to go for here is to make an audio controller. This will live somewhere in a game controller object, something that looks probably like this. We're just going to stick some kind of audio controller script on it that we write ourselves, right? This will be a singleton, right? Because this is some kind of global information that we want. We're going to have a public static audio controller instance that we're going to set to this, right? And we want this to be only a single one. So if we ever discover that the instance is not null and we're trying to make a new one, we should destroy ourselves, right? So we're going to make an instance of this. We're going to have it be a singleton to live in global memory. So everything can just go and access it by saying audio controller.instance, right? And we're going to spawn in an array of audio sources, or in our case, it'll be a linked list for the specific way we're doing this. So I have some kind of linked list of audio sources. And I at compile time, right, I have determined some kind of number of sources that we're going to have. And I'm going to loop, and I'm just going to make a bunch of sources. I'm going to go add component audio source to this game object, set some things to be default to false, and then add it to our linked list. Okay. So what we're doing here is we're setting basically like 100 or so sounds. We're going to add 100 audio sources to this one game object. And then we're going to just keep a linked list of that. So what that's going to let me do is now anytime anyone wants to play a sound, right, I'm going to have this play sound function, right? We're just going to take in an audio clip, a volume, a delay if you want to delay however much time that sound will take. And then we have this bool flag for importance, and you'll see where that comes from so far, right? So what we're going to do is we're going to look at the front of our linked list, right? If that value is already playing, then we know that something has gone wrong and then we have too many sources. So we'll either ignore the sound if there are too many sounds playing, or we'll, if it's flagged as important, we'll just replace whatever sound is using. So I have this bool important flag. So if a sound is really important, like if you win the game, you really want a sound to play, versus if you have some random bullet, you don't really care, right? So important is just a flag to say either we're going to overwrite the sound if it's full, or we're just going to ignore it if it's not important, right? And then, so once we have our source that we're going to play, we're going to set its clip to be whatever clip we pass in. We're going to set its volume to be whatever volume we want, so anywhere from 0 to 1. We're going to have options for delayed, and we're just going to play the source. So all we do is call source.play, right? And then what we do is we remove from the list and add it to the back of the queue. So at any time we're pulling from the front of the linked list, we're playing that sound and we're adding it to the back of the line to be cycled through over and over again. Okay? So this would be a really clean way of managing audio in your game, because anyone that wants to talk to the audio manager simply calls audio manager.instance.play. You pass in whatever audio clip you want, and then you simply have a working audio implementation. So this is a good example of combining kind of a pool of objects with a singleton to solve a very common problem that will come up. Okay? So this is all of our EGaDS information. If any of y'all are interested in learning more about game development, our Discord has a bunch of resources for these things. We do workshops roughly twice a month. We do both Unity workshops like this, and we do art workshops as well. So if any of that interests you, here's our information there. Otherwise, thank y'all for coming, and yeah, have a good hackathon.